Okay, so that is it for 120. I forgot to record the first part, so but you'll catch up from these two remaining. Now the next cell you have still, okay, now we're going back to the part. So they're both below. So we still have with this where our capacity is greater than demand. Okay, so applying this for the rest, for the remaining two. Okay, so I'm saying our capacity is 200, but our demand is 190. So meaning that the cells for 190, which they're buying, will give us selling price is this, 36,000 times 190. Okay. And then our variable cost will be equal to the reduced price, which is the reduced variable cost, which is 12,780 times the number of units, which is 190. Okay, so this time it gives me a profit of that much. And that's what you bring here. Okay. That's what 190. Then we go to the next one, which is still similar to what I've just done. But still we can see that capacity exceeds demand, and therefore you can only charge okay. So our capacity this time it's okay, remains 200, but our demand is just 120. Okay, so it's 120. It's saying that my cells will therefore be equal to the selling price, which is 36 times 120, which is demand. Okay, so something applies to this, that it is the reduced variable cost times 120. So giving me this. Where is the 12,780 coming from? It's coming from this note here, that if the capacity of the van is greater than demand, the variable cost is lowered by 10%. So our variable cost is 14,200. When reduced by 10%, you end up with 12,780. So that's how we get the figure. Okay, so guys, that's how we're supposed to do this number. Okay, now from this, I will try to explain. Not sure whether this will work. Why not? I'll try to explain minimax and then max regret and stuff like that. So I hope you're comfortable with how we get these figures right now. Okay, so let's look at now the decisions after coming up with the profit figure or whatever it is. Okay, how do we use it in terms of the decisions that normally try to cater for uncertainties that may arise? They try to minimize the uncertainties, okay, the decision making. So we can try out first max min, for example. Okay, max min decision. Allow me to remove this. Okay, so we're confident with this one now. Okay, so we want to apply max min. Decision. So I already talked about it. We say that you look at the minimum. Okay. So remember the goal is like which bus to use or which tractor, which lorry to buy or which van to buy, and therefore our basis is on what van gives us the best profit. Okay, so we look at it horizontally. Okay. So minimax. So minimum, the minimum, we know for sure that, okay, just borrow this from this side. So we know for sure that under 100, the minimum is this one here. Okay. Then under 150, the minimum is 2.3. Then under this one, the minimum is 2.7. Okay, I'm just borrowing these words since they are just nearby. Okay, so we're interested in which crate, which van can we buy, which van of which capacity should we buy. So minimum performance is as follows, and therefore our max min shall be, I think, this one here. Okay, that from this population you choose this sample. So that will be your answer, minimax. Let's look at max. I don't see anything much. We're supposed to show the formula that you had first max, that you had the maximum chosen first, the greatest chosen. So meaning you chose this, then in this one you would choose this one, then in this you would choose this. Okay, then after choosing those ones, then you say which one is the maximum again. This, and I think it's this one. So this will be your answer, right? So for the regret, may not work out well because of this, the fact that it is a 3 by, it is what, 2 row by column, it is a 2 by 3. So it won't give us the other diagonal zeros and something like that. So I allow me not to do that, which I thought is the most important, but unfortunately this question won't allow me to shine. However, I can maybe just comment on it, right? Which I think is fair enough. Okay, so what we do is we redraw the table. We redraw this, but putting in consideration regrets. So how do you choose the regrets? Regrets are chosen in a way that you choose the maximum. Now in this case, the maximum would be, for the first row, it will be 4,411,800. Okay, and then now this one here, we shall put it at a 0. Why? Because when you choose 4.4 million, and at this stage, the regret is 0. There's nothing you've lost because you're supposed to choose 4.41 and you've chosen 4.41. So ideally, there's no regret. Okay. The regret arises when you come this side now, for example. You're saying that you want to choose 2.39, but in choosing 2.39, you're saying you would have chosen 4.4. Why do you choose 2.39? Okay, so in choosing a lower value or a good performance for, a poor performance for a bigger value, there is a regret or is an opportunity that you're missing out. There's a profit you're giving away, what you're calling a regret. That's how we end up having the 4.1 minus this as our regret. Okay. Then for this side, the 2,180, we're saying still, why didn't you choose 4.41? Yeah. So you're choosing 218,000. You're missing out on a profit of this minus that. Okay, so it's how we end up having these regrets here, and you're having a 0. Because here, when you choose 4.4, it's the best, then there's no regret. Okay, so you go to the next row. The next row, the best figure, I think, is, okay, The other two are similar. I wonder why and how come. Is there an error or something or what? If they're similar, that's really interesting.
They are not supposed to be similar.
I thought this is supposed to be equal to this one here. Yeah.
So that we bought this drone and this generator.
This one, this side down.
And
So the same, nothing you can say or do, apart from knowing that that's the highest. Yeah.